In some parts open the turbine. Know some of the main components of. As I said, it should last approximately 40 minutes. Of a body, or a vapor chamber like this one, for example, on the other side too. And here also within this component. How does the turbine arrive, then? Roughly speaking, here we can block it or not, of steam entering it. So inside there are also turbine safety devices. That the standard that regulates steam turbines requires this to be done. Withstand tests are pressure up to 1.5 times, project pressure and so on. So now we're going to explore our carcass a little more. Of admission. So that's where all the steam comes from, okay. So basically here the steam. It will enter through here, as we saw in this case here. And as we said about the lift bar, so each valve here, it is regulated at a certain height. And going into more detail. Oh, so that's basically it. Here are some steam intake pipes. Okay, so imagine, gentlemen, that here we have a ring. This ring here, he goes. If it is a circle, send these control valves there. So, what do we have after that? Obviously, we will deduce this steam and we will understand that it is already leaving. So, in a certain ideal flow that prepares for application. And then he will find the turbine rotor here. So here now we can, maybe now, open our turbine here, right? Leave it more or less here. And then, as I was saying, he's coming here, from here, like that, right? So, this is how it is being designed. So imagine that he finds it there in the opposite direction. It's already written. So it will introduce a tangential displacement, an angular displacement of this pallet, and then all of them are hit. That will provide the torque, right, mechanic there on the axle. Right, generating output power on the turbine rotor shaft, okay. And then it goes. The steam passes between fixed, static elements. Fixed, immovable. That is, on the reeds and diaphragms or reed holders. In the case of electric reaction turbines, there is a slightly different concept. And then it generates all the torque. We are taking advantage of all this loss of steam energy to the escape region. So he will come out here. That's why there are reeds in the exhaust region here. A time to be able to handle this flow of steam that is being expanded, okay? So, that's basically the principle, right? We won't go into too much detail. Then we just have to show you too. To tell you a little more detail here. A diaphragm, which is where it is weak, which is a fixed reed plate in A. So he has this look here, right? And it has such an aerodynamic profile that it has a region called the throat, which is a calibrated measurement. That we do all the calculations to actually know what it is.